talk about what does it mean to create, first of all, a React application. Then we'll talk a little bit about what are functional components. We'll then talk about a few interesting capabilities of functional components and how we could benefit from them. And the best time to ask questions or make comments is anytime you have a question or a comment. So let's first talk about, what is a tool like React being used predominantly for? Well, predominantly we are interested in creating single-page applications. But what is a single-page application? If you think about a single-page application, the idea is, in the traditional applications we were used to creating, you would display a HTML page, and a user would be interacting with the page. They may select something, they may enter some data, they may click on a link. Whatever actions they perform, we make a request to the server, and the server, of course, would do whatever processing it wants to do, and it would regenerate an entire HTML page, which is then sent to the browser. And the browser, of course, would render the entire HTML page, and the cycle would repeat. Now, the disadvantage of this is we make a round trip to get an entire page of data back to the browser, and then we are redisplaying the data on the browser, and if there is a lot of content to be displayed, we are wasting on getting all the data we don't need to get back because most of them are on the browser side already, and second, to re-render all the data on the browser side. So a single-page application gives us the idea. Here's a way to think about what a single-page application is, so to say, metaphorically speaking. Imagine that grandma gave us a beautiful photo frame and said, here's a photo frame for you, keep this around, and now you have a photo frame. But as time goes on and the seasons change, you want to change the photo in the photo frame. You may want to put the kids' photos in the photos frame. They start growing up, you want to put more photos. So as time goes on, you're going to keep changing things. So the frame is exactly the same, but you remove the photo and put new photo back in. If you think about it that way, you first render a HTML page, but imagine that HTML page is your photo frame. And within that, you're going to put a little content. And when a user interacts with the application, you send a request to the server, but you don't bring back an HTML content entirely, but you bring back enough of the data. And then once the data arrives, you then start populating the data within some areas within that photo frame or within the HTML page. Now, if that is what we are doing, what does it really mean from the programming point of view to create a single-page application? And you can say creating a single-page application involves two things fundamentally. And the first is to make an AJAX request. So you make a request to the server and say, hey, server, here is the information I want, here is the data I want to update, so you send a request. And the response that comes back is going to be some kind of a data. Now, this also shows our field where things change, but sometimes terms are created based on what we do at the time. AJAX initially stood for asynchronous JavaScript and XML. Now, we don't usually do XML these days as much, I hope, because that's brutal. But instead, we may get back the data using JSON. So it's still called AJAX, but you could call it as AJAX if you want to, doesn't matter. But the point is you're getting back data. So fundamentally, one of the things you need to do is to make asynchronous call, get the data from the server, and process it on the client side. Now, as it turns out, that's very easy, right? Because all you have to do is to use some kind of a library to make a request to the server. You can use the XML HTTP request object if you really wanted to. You could use different libraries, including Axios that a lot of people use today. So that's the easy part. Now the data comes back to the client side, the browser. What do? Well, the minute you get the data back from the browser, you need to update the DOM, which is the document object model. But what does it mean to update the DOM model? Well, you have an HTML page with a lot of content on it, and in this HTML page, what you're interested in modifying is this part right here, let's say. Well, you have to identify that part specifically in the document compared to all the other things you want to get to it. And the minute you get to it, what do? Then you say, well, on that particular part, here are the changes I want to make, and you start having to do the DOM manipulation. Now, if you have never done DOM manipulation, the first day you do it, it looks really interesting. And the second day you do it, and the third day you do it, and then as time goes on, you realize that the job to manipulate the DOM should be given to people in the prison. Because nobody in the free world should be asked to manipulate the DOM, because it's painful. You have to know exactly what elements to change, what functions to call, and it becomes really painful. And it becomes error prone. And the minute the DOM structure changes even slightly, you have to modify the code. And what this ends up doing is you spend a lot of time and effort modifying code, and for very little result, and this is not really a very nice way to continue programming. It's too brittle. So this is where libraries really come in. So libraries like React say, why don't you focus on your business logic? Why don't you focus on what you want to do? Let's think about this for a minute. You will, thinking about the transition, not just in programming, but in life as well. I travel around a lot, so which means I rent cars and I drive around. But I will tell you, you will never ever see me do one thing. You will never see me ever drive a stick shift car. I don't understand why any human would ever drive a stick shift car. I sit next to somebody who's driving car and they keep doing this. I'm like, why? Why don't you just drive? And they keep putting the clutch and they keep pressing their foot. I don't understand this. Like, that's too much of effort. You will never see me do two things in life: drive a stick shift and manipulate the DOM directly. Now, if you ask me, I would probably sit in a car, put it on a drive. This is called auto transmission. And you put on cruise, and you don't have to worry about driving. You focus on where you want to go, you have a nice conversation with the person, make sure you don't run over somebody on the road, and you get to your destination. Well, you could say, maybe that's kind of like using jQuery, right? jQuery doesn't solve your problem. jQuery gives you that pill. You take the pill, it seems like you don't have the pain for 2 hours. Then it keeps coming back, right? But I am more of that Uber or a Lyft kind of a person. I get out in the airport, I call Uber or Lyft, I get into the back seat, I sit down, open my laptop, start working, and the driver says, where do you want to go? I say, here's what I want to go. And the driver says, which road do you want me to take? I say, take me the one that is safest. I just don't care which way you go, as long as you get me to the place where I want to go. This is kind of what these libraries really are. So this takes us from the imperative way of doing things, where you do everything, to more of a declarative way of doing things, where you say where you want to go, but don't bother with the implementation of how to get you there. So this is what fundamentally React, Vue, Angular, all of these tools are really trying to take away from us, that drudgery of having to write the code to manipulate the DOM. So you can say, here is the content I want to display, you take care of the rest of the work. So that's basically what we are interested in doing, and that's where the libraries really come in. So having said that in here, now let's talk about how can we use these kinds of libraries. So this is where components come in. So we want to create a React application, but the question I want to ask is, what is a component? Well, think of a component as an object or abstraction. I don't want you to think of an object as an object-oriented programming object, but think of an object as an abstraction. It's the thing, right? So it's an abstraction that will give us a view of certain content. For example, As I travel around the world, I want to know what the weather is going to be. I want to know what the weather is, here in Bangalore this week. I want to know what it is in Denver next week maybe, and the following week I want to know how it is in Toronto. So I want to know what the weather is, but I don't want to be duplicating the code to write that and display it over and over. So I may create a weather component. A weather component says, tell me the name of the city you are interested in, and I will tell you the temperature and the forecast for that city. Now, creating that abstraction, what did we achieve? That abstraction allows us to create 3 versions or 3 instances of that component, one representing the weather in Bangalore, one in Denver, one in Toronto. So I don't duplicate my code, duplicate my effort. I simply instantiate this abstraction 3 times, and I say, hey, you tell me the weather for Bangalore, you tell me Denver, you tell me about Toronto, and now I have the weather for the 3 different cities to display. Now, abstraction is what we program with every single day. Your abstraction could be using classes. Now, this is where I think our field has gone in a wrong direction. Not that they meant it to be going in the wrong direction, but a lot of times we perceive things based on what we are exposed to. I've been programming for about 35 years now. When I started programming, there was no object-oriented programming, at least not in the mainstream. So we wrote code using functions. Functions represented abstractions for us. Then along the way came object-oriented programming. People started creating classes and objects. And there's a generation of programmers who were actually born after languages like Java and C# became mainstream. And you go to them and say, let's create an abstraction, they create a class. They cannot think of creating a function in general, but there's no reason for abstractions to be classes. Abstractions can be functions, abstractions can be classes as well. React is an interesting example of that because they started creating abstractions using classes, but in React 16 they said, wait, we don't have to do this. We could create abstractions using functions, and that's what a functional component really is. So a component is an abstraction. You can create that abstraction using a class, which is called a class-based component, or you can create that abstraction using a function, in which case it's called the functional component. So it's purely an abstraction. Can I write this abstraction as a class? Absolutely. Can I write this abstraction as a function? Yes, starting with React 16. What would you want to do moving forward? Well, their recommendation is to go towards a functional component rather than a class-based component, and that's what we want to see in here. So, okay, we want to create a component. A component is this abstraction. We want to be able to display stuff for certain things in this abstraction. That's great, we can do it. But then, what is really a functional component? At the very fundamental level, a functional component is a function. And it's a function that doesn't take any arguments per se, but you can pass some arguments if you want to. Those arguments or parameters that you pass to it are the properties of a component. For example, I want to display the temperature in Bangalore. Well, that's great, but do you want to, in what unit of measure you want to use to display the components? And you know that there are only 2 units of measures in the world, right? One that is civilized and mature, as the entire world uses, and one that is ancient as my country uses, which is what we do, Fahrenheit. And interesting enough, when I was born, we used Fahrenheit in India. I'm kind of dating to you. And I never used Celsius in my life. Before they decided to change to Celsius, I left the country. So I never ever lived in my life where they use Celsius. So when people say it's 20 degrees Celsius, I need all the computing power in the world to understand what that really feels like, right? If you tell me it's 80 degrees Fahrenheit, I get it, because that's what I'm used to in my entire life. So we can use Fahrenheit. Now you can say, hey, component, you want to display this temperature. If I don't tell you to use a certain unit, use the civilized or the evolved unit the world uses. So it says, oh, the temperature is 21 degrees Celsius. But then I say, oh, no, I want you to tell me in Fahrenheit. Then it tells me, oh, the temperature is maybe 76 degrees Fahrenheit. So a property is, think of a property not as a data, But think of a property as like a configuration that you can send to a component. So like this component is going to pull the data for temperature, but I configure it to represent in Celsius or Fahrenheit. That could be a property, for example. So anytime I want to type, it disappears. That's kind of interesting, right? So I guess I'm going to do the entire React talk by talking rather than typing. Okay, so essentially we talked about what a functional component is. So how do we create a component? At a very fundamental level, your component is a function, and minimally all you want to do is you want to return back from a functional component a little snippet of a DOM structure you want to display. Well, okay, so you want to display a DOM structure, but what kind of DOM structure do you want to display? Well, what React says is, if you start manipulating the DOM, it becomes really, really expensive, time-consuming, error-prone, tedious. So why don't you give me what's called a virtual DOM? So what is a virtual DOM? Let's step back for a minute. Forget about what we're talking about right now. Imagine you are creating a Windows application, like a desktop application. It could be Windows UI. It could be Swing application, whatever it is. But if you've got a lot of graphics to do on it, it becomes extremely slow. So typically what you do is some kind of a double buffering, right? You draw into a buffer, and when you finish rendering into the buffer, you then swap out the real content on the view with what you drew in the double buffering. In a similar way, a virtual DOM is just a structure that you're building in your code. And the minute you finish building the structure, you have on one hand the real DOM, which is in the browser, and you have the virtual DOM that you created. Naively thinking, imagine these are like fingers on my hand, and maybe I want to color one of my fingers. I want to put a ring on one of my fingers. So what React does is, it takes your real DOM and takes your virtual DOM, and literally it walks through the hierarchy of the DOM. You can imagine a computer is much better and faster in doing this than you and I will be in code. So they compare the DOM to what is there in the virtual DOM. If they are exactly the same, it just leaves it in place, doesn't do anything. If it is, has an attribute that's different, it modifies that attribute, like coloring my fingernail. If there is an extra element, for example, it puts on the ring on that. If an element is removed, it removes that as well. So in other words, it updates the real DOM based on the structure of the virtual DOM. And since it's selectively updating the DOM, that's wicked fast compared to we blowing away an entire DOM structure and recreating the whole thing. So the benefit of this is you get performance with developer productivity. You're not writing a lot of code to squeeze that performance. You write as little as you can and let the tool do the job to give you the performance. That's where the benefit really comes in. So enough talking, assuming I can type right now. Let's talk about how we can actually create this component and how we can work with it. So let's think about how this is going to work. So I'm going to first of all go to the source, and at the very top level, what you have is this thing called the app component. So you can see that this app component, think of this like the mother of all components, and this is at the very top level. Your application is going to render the app component. If you're curious how this gets rendered, actually, there is a HTML page, and in the HTML page, basically, they are taking the content returned by this component, and they're sticking that into that page. That's all it is, not a whole lot. Now that we have this component in here, what I would typically what you do is you put things under this particular component, whatever you want to say. So I want to, let's say, just put a few dashes in here for now. That's all I have right here. So in this case, I'm going to go back here and do a start on this application so we can quickly take a look at this particular application as it runs through. And in here, what you should notice is the 3 dashes I entered, which is sitting right there. So not a whole lot, right? but you don't put anything under the app in general. The reason is your application structure is going to evolve and change quite a bit. So this is more like an entry point or a gateway. You don't put a whole lot in here. So what you're going to do here is you're going to call in another component called the greet component, let's say, and I'm going to call the greet component. But where in the world is the greet component coming from? So you say import greet from, and I'm going to say from greet, let's say, .js. So I'm going to bring this in from the greet component. That's all you're saying. Now, before we go further here, React doesn't have any clue about HTML. In fact, React could be for rendering on a browser. React could be used to render in a native image. So you could be using it on a smartphone. And so on a smartphone, if you have a native application, you're not going to be using HTML. You could be using whatever the native platform is going to support. So for that reason, that greet is a component. And a component can be translated to an underlying representation. So a component can translate to HTML. Component could be translated to the iOS kind of APIs that are available, what have you, to the native images. Now, so far so good. But one thing they did was they did something a little bit clever. Well, is it clever or is it silly is debatable. But they decided to call this as div. Well, div is not HTML. It just has a name that you are familiar with in HTML, but that's a React component. So essentially, div is a React component that translates to the div HTML when you render to the browser. So similarly, for almost every single HTML element, you have a corresponding React element, React component. So it's important. Sometimes you lose sight of it. And then you start thinking you are writing HTML. It looks like HTML. It feels like HTML, but it's not HTML, right? It's components that you're using right here. So now that we want to use a greet, what are we going to do next? I'm going to go ahead and say source greet.js. And this greet.js, what am I going to do in here? I'm going to, first of all, create a function, and I'm going to go ahead and export that function. If you notice over here, in the case of the app component we just saw, you can see that in this case, the function app is created, and they are doing an export default on that particular function, which is exactly what you can do here as well. So I'm going to go back to the source greet.js, and what I can do here is I can say export default function, and I don't even need to give a name to it if I don't care for it. Name doesn't mean anything. You can export that function directly. If you want to, you can call it whatever you want to call it, right? You can call it greet. Whatever name you give it doesn't really matter. So if you don't care for a name, don't give it. But in this case, I'm going to return and simply return a 3 dots in here. That's all I'm going to return at this point, nothing else. You can see the dashes became the dots right now. That's basically rendering that particular component. So you can render whatever that may make sense to you from here. So in this case, what do I want to do? I want to render something in this case. So what I'm going to render here, let's simply render just a little div, which is, as you know, the React component. And I'm going to render a div component. And within this, I'm going to render a span React component, which says hello. And I'm going to say span right there. And I'm going to be saving that right there, as you can see. So as a result, the output says hello, which is what we are rendering right now. So at the very rudimentary level, that's basically what we are doing. We are simply rendering the content of a component. Now, as you can imagine, if I want to render multiple components, it becomes almost trivial, isn't it? For example, if I were to go back to the greet component right now, and in the greet component, I could say, I want to take in a property right there. So you could say, here comes props that I want to bring in. And what do I want to render right in here? You could say I want to render right in there. In this case, you could say, I want to render the props dot, maybe a message, right, that I want to render. So you could say, I want to render a message. So this is how you can bring in properties that you want to render. So if I want to send a message and render it, I can go back to the source app.js, and in this case, I can say render greet a message, and the message I want to render in this particular case is going to be, well, what do I want to render? I'm going to say there, right? So I want to render hello there as a message. So you can see it says hello there as the message being rendered. And I can also say hello and maybe how are you as a message I want to render. And that's an instance of a component I'm rendering again. So they're just properties coming in. Now that we are able to render that, I'll come back to this in a minute, but if I go back to, in this case, the greet component, you can see that in this case, you can just do a few JavaScript gymnastics here. It has nothing to do with the React, but writing a bit more elegant code. You can say, I can actually do destructuring. So why bother about props as a whole? I just want to get a message here. So I can come back here and throw away the props and simply use a message. You can do that, and that's no different in the output, exactly the same. So this is, again, like nothing to do with the React. You're simply using the destructuring to extract the message from the properties if you want to use it. So that shows us how properties are handled, and you can send properties from the parent object, if you will, or a parent component, as you see here, into the child component. This also illustrates how easy it was to create a greet component, the abstraction, and repeat it twice. And that's why it's important to know it's an abstraction. And this is one of the things I would emphasize we need to do as programmers, is at some point we need to keep in mind that we shouldn't merge concepts and implementations into one. We tend to do that sometimes along the way. And then you walk around thinking abstractions mean classes. Then you are in a shock when somebody says you don't need a class. Your mind cannot think that you can actually do things without a class. That becomes really painful. So this is a component. It's an abstraction, and you can create it using classes, as we did in React before. You can create it using functions, as we are doing it now, and you can run multiple versions of a function, multiple instances of the abstraction that you are using, if you will. All right, so we saw how we can use this particular abstraction in here. Let's get rid of that for a minute. Going back to this one, let's talk about something else that we can do right now. So in here, you can see the greet appears, and I'm going to show you a little silly example to illustrate this particular problem. So I don't need the message anymore, so I'm going to get rid of that from there and get rid of that from here as well. But I am going to say up here, maybe I want to display a different message, if you will. So in this case, what you could potentially do. So one of the constraints you're going to run into when it comes to functional components is these are really functions. And this function will be rendered, meaning it'll be called, and it'll be re-rendered, meaning it'll be called again to represent a particular component instance that's being displayed. Now, if it's a class, you know you can pollute a class with fields. And I use the word pollute because that's what we do, right? When you start writing classes, what do you do? The first thing, you throw some fields into it. And somebody says, why'd you do it? And you're kind of like, what do you mean? I need fields, don't I? So we have been polluting classes with fields more than we need. Well, obviously, a function doesn't have a field. So now you're like, gosh, how do I maintain a state in this particular case if it's a function? So we'll get to that in a minute. But there are times when the function is rendered, you want to do some action. Like what? For example, you may, when a function is rendered, a component is rendered, you may want to go out and get the data from the server. And once the data comes from the server, you want to display it. Now, obviously, this is one of the things, honestly, which is the most difficult in programming, not because the concept is different, it's because, again, of our constraints and exposures. I spent about maybe 25 years programming in languages like C++, Java, and C# and so on. And when I started learning JavaScript, what was really hard for me is not the language JavaScript. Syntactically, JavaScript syntax is not very different, right? You remove the types, you kind of go from Java or C# to JavaScript by removing stuff. So the syntax is not very different. What I found the most difficult was really learning and thinking to program asynchronously. Because in languages like Java and C# and C++, and most of the other languages, we are used to doing synchronous programming. You want the data, you make a call to get the data, you get the data, and you move on. Now the problem is, imagine you render a component. When you come in to render a component, you say, okay, hang on a second, I need to get the data from the server before I can render it. Now you have a blank screen, and you make a request to the server. And the server is taking a little bit of time to respond. Now, what does a little bit of time really mean? As a human being, there is things that we have limitations. Michael is an amazing magician, and I've seen his magic several times. And he is wicked quick in doing things. As he said, magic is really doing things so fast you don't know it really happened. And he would, do things and you're like, whoa, how did that happen? Well, the reason is a human mind, human brain needs 250 milliseconds to know that something actually happened. And Michael is faster than 250 milliseconds. If I do the same magic that Michael does, you're going to see every action I take because my speed is this, right? But his speed is wicked fast. So if something happens within 250 milliseconds, boom, your eyes don't even notice it happened. So 250 milliseconds is to your advantage. 500 milliseconds, what's that? That's called half a second, right? And if you do things in half a second, a user's eyebrow just about begins to raise. What happened? Is it slow? Oh, there it is, right? And they don't even notice it most often. And 2 seconds is called eternity. And what happens, right? You go to the application, 2 seconds goes by, and the user is thinking, oh my gosh, this application is not responding. Let me help it by hitting the refresh button, right? As if this is somehow is going to make the application better. Now what happened? There's not one thread, there are 2 threads running on the server, right? So this is like going to somebody who is not functioning faster, go faster. And they're like, oh, and they freak out, right? This is silly. So you have a very short window of time, which is half a second to respond. So now you say, wait, if my component is being rendered, I make a request to the server, and the server is going to take a little bit of a network delay, a little bit of time to take the request, a little time to go to the database, a little time to process that little time, and guess what? All that little time quickly adds up. Which means the user is going to keep hitting the refresh button. This is going to get really worse. So what you do is you say, hey, component, I'm going to immediately render. Now, the beauty of the world is we humans are tuned to instant gratification, right? I mean, you go to a store. Imagine this for a minute, right? You walk into a store, and there's somebody busy helping somebody else. What do? You kind of look around for a few minutes, and you look at them, and they don't pay attention to you. So what do? You probably just leave because you're angry. They never responded to you, right? Or you go bother them. You say, hey, I'm here. You didn't even notice it. But on the other hand, you walk into a store, and the door dings, and the person who is busy helping the customer is still talking to the customer and says, oh, thanks for coming, I'll be with you. And they start talking to the person. You waited for 15 minutes. Why? Because you felt like you were important, even though you know you're not. And the point really is that little response really says, hey, I saw you, I noticed you, I'm working on it, and I'll get back to you. So when a page is able to display information right away, it's not the stuff the user wants, but the user is so happy, right? It's like, gosh, I saw the response. That means the app is working. I'm going to give the benefit of doubt. Now you can put a reloading button, right? If that is not enough, if you really want to make the user happy, put a picture of a cat, right? They're just absolutely happy, right? So you do that in the rendering, and now you say, I want to go make a request to the server. Well, this is why we need asynchronous requests, because you want to not block on the request. So you immediately respond to the user. On the background, you make an asynchronous request, and the request goes to the server, does the processing, gets the response back, and now you say, aha, now that I got the response back or an error, I can now update the view with that updated information. So in this case, what you're going to do in order to do that is to do what is called an effect. So you're going to import right here a use effect, and this is going to come from a React right there. So what is an effect? Well, they call them as hooks, but an effect is simply a way for you to perform an operation on a component, typically as an asynchronous operation. So you say use effect right there, and what am I going to do in the use effect? I'm going to do something absolutely silly just to illustrate this particular idea. So I am going to go ahead and write a little function right there in here. And within this function, I'm going to simply output, let's say over here, called. So I'm going to simply say called and put those words in there, right there in the use effect. So now you can see it says called, and I want to see that being displayed when I render this particular component. So if I go back here and look at the console right now, and if I refresh it, you can see in the bottom, it says called and called. Is it a good practice to do console logs like this? No, right? And in fact, you need to have a sense of bad code, and there is one person in this room who has that sense. I don't know if you noticed it, because the minute I wrote console log, there were 2 sneezes from this part of the room, right? I love that kind of sense, right? So every time you write a bad code, you sneeze. You know, don't do it, undo the change. But it illustrates the point, right? So you basically are saying, hey, I want to render that. Here is a called. If I go back to this one, I'm going to just remove that for a second, hit the refresh button, you can see called. Well, you see called being called twice. Well, we'll see what that is. But the idea really is you are calling that function, which in turn calls that body of code for you. However, remember, I want to do this asynchronously. Well, obviously, I can call a function of the server. I can do an asynchronous call, all those good stuff. But I don't want to do any of that right now. So instead, what I'm going to do here is to use a very poor man's approach, a set timeout. And the set timeout says, take about 5 seconds to do this work. And at the end of the 5 seconds, simply go ahead and say, in this case, let's say it's going to simply output, let's say called and display it. Not working. Okay, so essentially, we are just taking a 5-second delay and doing this work, as you can see in here, isn't it? Well, when I look at the output of this code right now, what you're going to see is there was no display in the bottom, as you can see, and 5 seconds later, the called appeared right there. So that's basically showing, I'm going to clear that out and show it again. So I run, okay, there you go, a little delay. Okay, so essentially, when you run the code right there, so you can see that it doesn't display any message right now, and 5 seconds goes by, you can see called was being called. But the problem with this approach is the use effect function says anytime a function is rendered, call that effect. Now you're going to get into a mess right now. When you call the use effect, the effect may go send the data to the server, and the server sends a response back. It updates the state, which we'll see how it does in a few minutes, and update the state. And the minute the state is updated, what's going to happen? The component is going to re-render. And when the component is re-rendered, what's going to happen? You're going to have the use effect being called. And what does the use effect do? Oh, thanks for calling, goes back to the server and gets the data. When the data comes over, what's going to happen? It's going to update the state. When the state is updated, the component gets re-rendered. Now what's going to happen? It says, oh, thanks for calling, and it goes back to the server, and this is going to be a never-ending, this is like you call, and that says render. Oh, you rendered, I'm going to call again. Now you're in this loop, endless loop, which doesn't make any sense. Now this is where one of the things I always insist on programmers to do is program with intention. Live with intention. When you convey what you want to do, right? I'm busy working, my children ask me something, and I'm just continuing to code, or I'm just blabbering something. They get annoyed, I get angry, we scream at each other. But a simple thing, right? I'm sitting and working, a kid comes over and says, got a question, you say, I am busy doing something right now, can I talk to you in 30 minutes? And immediately it's like, oh, thanks, and they go away. And 30 minutes later, they come back and we talk, right? That is living with intention. You're not ignoring them. You're not pretending you have something more important to do, but you're being direct and say, hey, I'm busy right now. I won't talk to you right now. Well, similarly, what if we can program with intention? When you program with intention, you're clearly telling the person reading the code, this is what I am doing. You better be aware of it. All that I said to show that they don't program with intention in this particular case. It's very convoluted, unfortunately. But let's understand how they implemented it. The way the use effect works is when you call the use effect function, you can pass as a second argument yet another object right in here. So this object you can pass here, you can pass some object to this. The way the use effect actually works is, oh, by the way, just as another side note I want you to think about, right? These are the things in life that we should be constantly asking the question, right? I've got a theory, and the theory is that those who design bathrooms in a hotel has never taken a shower. Because every time I go to a hotel, and the shower is the worst place. I bang my hands on this, the shower is in an awkward place, and I'm like, who designed this? And this happens in every single hotel. So the theory I have is that those who design hotel bathrooms have never showered. Likewise, those who design an auditorium or a classroom never ever sat and listened to a lecture. Because why would they put the stupid thing here, blocking the view for a good number of people in the room when nobody can see it? This is called empathy. And when you design, you got to ask the question, how does this feel? If I ask you, how does it feel? He's like, awesome. How does it feel? This sucks, right? How could this be a good way of doing things, right? So maybe you can take a note of it, right? Get rid of that stupid thing from there, because the people on this side of the room cannot see this. And that is what we need to be thinking, right? When you do the job, you ask the question, does this damn thing work, right? And if it doesn't, get rid of it. Okay, now back to the scheduled program. What were we talking about? Yes, program with intention. Design with intention of people actually using it, right? So essentially in this case, the use effect function says, you can give me an optional object as an argument. If you give me an object, I will compare this object to what you gave me the last time. And if the value is the same as the one you gave me the last time, I will not run the effect. If the value is different, I will run the effect. Is that sensible? No. But it's convoluted logic, isn't it? But instead, if you just told me what to do, if you gave me a function, say, just run once or something like, or run on change, that would be easy to know. But that's kind of what they implemented. It took me a while to really understand that particular idea. But the point really is, when you're running this code, notice in here, I'm going to pass to this square bracket right there. When I pass a square bracket, the very first time you call useEffect for this component, the component says, what did you send me the last time? Well, there was no last time. This is the first time. Oh, run the component function and store the square bracket in memory. Well, the next time the component is rendered, you send a square bracket. And it says, oh, you gave me an empty array the last time. You gave me an empty array this time. They are equal. I will not run the component. So essentially, run the effect. So essentially, when you put a square bracket here, you will no longer render it on the second call or the third call to that function. So as a result now, when a component is rendered the very first time, you make a request to the server, and the server comes back with a response, and you take the data, put that in the state, and the component is re-rendered, and the effect is called, and the effect says, oh, you ran this with the empty array before, you're running again with the empty array again, I will not make the call to the server, end of story, right? So that vicious cycle of calling it repeatedly simply goes away. So that is basically the idea of effects and how they get called. But we talked about the effect, but likewise we want to think about the state as well. In a component, for example, when you are creating a class-based component, you can put the states as a field in some form or the other. But what about this one? How do you keep those fields in here? So what I'm going to do here is to create, in this case, a label, and the label is going to be HTML, let's say, for, and this is going to be for a name, and I would say this is going to be a name label I want to create right here. Then I'm going to say here is an input, and type is equal to is going to be input, and I'm going, in this particular case, let's say, actually, I don't even care about it right now. And I'm going to say that this is going to be the ID that I want to provide for the name. And I'm going to then say this is going to be an input that I want to provide right in there. So let's start with that first. So then, of course, I can simply put a little break here if I want to, or design it properly using a CSS, and you can see what it's going to show you. So essentially, in this particular case, you can build the stuff with it. Let's take a look at what I did wrong in here. So I want to provide a label and HTML for that particular name, and I provided the name, and I have an input where I say ID is equal to that, and of course this is going to be the input I'm creating right there. So I can, type here, right? Whatever name I want to type, I can type it in there, and I want that to be appearing right in there. So how do I really bring that up and display in here as a state information? So for that, the first thing we're going to do here is to bring in an onChange is equal to, and we're going to provide a method here that we're going to implement. So in this case, I'm going to say, we'll call it as a set name, and I'm going to take this target of the event, and I'm going to get the value out of it and set that as the name. And obviously, the target that I'm going to receive is from the element, the event that I'm going to receive right in here. So onChange set name, and I'm going to call this one. What in the world is a set name? This is where we will say use state. And within the function, I'm going to say constant name, name, comma set name is equal to use state, and I'm going to provide an empty like so. This is one other thing I'm not super excited about. And the reason is, when you develop things, you want to minimize the chances of errors in general. A good system, I'll tell you how appreciative I am. Again, I'm a big fan of good. I cannot design really well, but I can complain about designs really well. By the way, that's actually a good thing, right? Because you want people who can complain so the people who can create better, right? You need both. I'm really good at complaining. But I'll tell you, I really appreciate when people do really, really sensible things. I was extremely tired one night. I worked all through the night, started driving in the morning. Yeah, you could say, Venkat, you shouldn't be driving when you're really not, awake. And I had to fill in gas into my car. I pulled to the gas station. And I need to fill gas before I can go home, but I'm very sleepy. And I go drag this, I take the little nozzle, I'm trying to fill the gas. It just wouldn't work. And I'm like, why wouldn't you work? I'm tired, I want to go home. Can you please fill the gas? And then I did this and I said, let me see what's going on. And that's when I found out what I was holding is a diesel nozzle. Now, just think about this for a minute, right? Assume they allowed me to put diesel into my gasoline car. What would have happened? Disaster, right? And the people who designed this are genius. They designed the nozzle for a diesel in a different shape than a nozzle for petrol, gasoline. So you cannot fit that in. Isn't that cool? Yeah. You say, yeah. I said the same thing about a month ago. And one guy in the audience raised the hand. I said, yes. And he said, I wish my sister stopped at that point. I said, what happened? And he said she went and got a funnel. Anyway, so the point really is, you can never make anything foolproof, right? That's the corollary to good design, right? You can put all your effort designing. Guess what's going to happen? The speaker will then stand here and talk, right? And he's like, I can still see the screen, right? Go figure. Okay, so the point really is, when you're designing this, the use state, unfortunately, the way this works is, it works based on the order in which you are evaluating. You don't need to show me the numbers. I'm good at timing. I got to watch. So thank you. So essentially, the idea is this. When you have the use state, it goes through a particular sequence. So the first one, the second one, and the third one. And what they expect you to do is every time you re-render this component, it better be the same sequence in which you run the use state. That's how they know which the state is. What that means is, if you were ever to put a logic in the code, like an if statement, and initialize one state versus another, your code is going to be broken, right? You will pull in the wrong state, so don't do that. So essentially, in this case, we are saying here is a set state, and I'm going to change the state right here. Then I come in here, and I'm going to display the name that we have like so. So if I go back to this code right here, you can see hello, but I'm going to type Sam right there, and you can see it appears right away. But what actually happened? It first of all, as you started typing it, it first starts by calling the onChange, which then takes the event and takes the target of the event and the value of the event and calls the set name, which is the state. And when that happens, then React says, gosh, I modified the state asynchronously, and then I'm going to re-render the component. And when the component is re-rendered, in fact, we can see this right here just for this purpose. So I can go back here, and I can say in here, let's say in this case, called with, and let's go ahead and output the name like so, and just for the fun of it, right? So we can take a look at it right here. So if I go back here and refresh this and try this again, so as I am typing over here, ROB, you can see how many times that called with was called, right? So it's just re-rendering it as you are running through and displaying the content right there. So essentially, the idea here is that when you perform an user interaction, you are then calling a function for handling that event, which in turn updates your state. asynchronously. And when your state is updated asynchronously, that triggers a re-rendering of the component. And when the component is re-rendered, you run through the whole thing again. But now, when you call the use state, this is an initial data that you gave for the state. And remember, it's order-based. So it says, oh, the first state, go get it. It doesn't exist. Oh, initialize with the value I gave, in this example, empty, and return it. And name contains the value that you initialized, and set name is a function that will asynchronously change that state. When you modify the name, it sends a request to change that state. The state now changes to the value you gave. That re-renders the component. When the component is re-rendered, the function gets called. It calls use state with a double quote in this example. It says, oh, no, we already have the state. We don't need your initial value. We'll give you the value we stored, and the name becomes a value you set previously, and then the cycle repeats. So we talked about the use effect. We talked about the use state. A use state and use effect, both of them really are hooks. And the word use, this is a part I like actually. The word use is merely a convention. That's what it is. There is no specific meaning to the word use. You can write your own hooks. And you say, oh my gosh, I'm going to write my hook. What does that mean? You write a function. That's it, right? But don't tell this to the boss. Tell the boss, I spent all night writing a hook. And they're like, oh my gosh, that's awesome. We'll give you a raise. So essentially, you write a function. And you just call it as use something, right? And then it becomes a hook. And you can just call it, and it does whatever it wants to do. That's a very simple concept. And I have to admit, the concept of hook is intimidating because of the name they gave, but it's a very nice and simple concept, except for a few of the things I mentioned that are a bit rough edges. So that shows you how we can render this. Now, that's the fundamental of what components do. And from here on, you can throw in more bells and whistles into it, and you can start building more into it. But that's really the fundamental concept of how this is actually working and how React components are built. As you can imagine here, when you want to do more complex things, your greet component itself potentially may bring in other components. Why potential? In fact, we did. We brought in a label component. We brought in an input component. We brought in a sample component, span component. We also brought in a div component. That is the aggregation hierarchy, right? So you don't use inheritance in React. You use aggregation. So there are different ways to model a system. This is aggregation-based modeling. Your app component aggregates any number of components, in this case, the greet component. Your greet component can aggregate any number of components. In this case, it aggregates the div component, the label component, and so on. Remember how I passed the message earlier to the greet? That is exactly how you're passing HTML for and ID and onChange are just properties you're passing to that particular component. This is where you need to keep in your mind you are dealing with React components, not HTML. It begins to blend at some point, but it's important for us to be awake and aware of it so we don't get confused between the two. Then it becomes an easy ride. I have written production systems with React. I do have to say that I really like React for the ease of development. I teach multiple different courses on a lot of different frameworks that are out there. I've done extensive training on React, Angular, and so on. But at the end of the day, I've written more code in React than anything else. But I'm also a huge fan of test-driven development. I didn't show you any testing today, but I wouldn't write these code without writing a test. If that is something you're interested in, I have a talk on test driving React applications sometime during this week. I don't remember exactly when, so I can see you there if that's of interest to you. Hope that was useful. That's all I have. Thank you.